Hello class, today what we're going to talk about is solving radical equations. And what this is, these are equations that have a radical sign, like cube root of x equals 3 or something like that. And the way we do this is step one, we got to get the radical all by itself. If necessary, sometimes it's already there, but sometimes not. If it has anything next to the radical, we've got to move that stuff over. Then we raise each side of the equation to the same exponent to eliminate the radical and to give us a linear equation or a quadratic equation or something else that we already know how to solve. And then we just solve that. All right? So let's do some examples here. Okay, so we've got two examples, A and B. So first one, 2 times the square root of x plus 1 equals 4. Step one, isolate the radical. That means this 2 has to go away. Now, one thing that's very important, you will never ever distribute anything into the radical. It's not happening. Don't try to do it because it's going to screw everything up. Instead, what we're going to do is divide the 2 out. Right? So we divide both sides by 2, and that gives us the square root of x plus 1 equals 2. Now we have the radical all by itself, so we're going to undo square rooting. The opposite of square root is to square. So we're going to square both sides. That's going to cancel out our square root over here and give us x plus 1 equals 4. So subtract 1 from both sides and x equals 3. Okay? Always a good idea to check it. And here it is. Take that 3, plug it back in, and it works out to 4 equals 4. And it does. So x equals 3 is a good answer. All right, let's do problem B there. So first, just write the problem down. Now check, is our cube root here all by itself on this side of the equal sign? And no, it's not. It's got a minus 1. So we've got to get rid of the minus 1. One thing that's very, very important, you cannot combine the minus 1 with this minus 9. This 9 is under the radical sign. The 1 is not. They don't get combined together. So instead, what we need to do is just get rid of it, move it over here. So we're going to add 1 to both sides. So we have the cube root of 2x minus 9 equals 3. Now we need to get rid of the cube root. And to get rid of the cube root, we cube it. So we cube both sides, raise each side to the third power. So this is just going to turn into 2x minus 9, and 3 cubed is 27. And now we've got a linear function. We know how to solve those. We've been doing that since middle school. So add 9, divide by 2, x equals 18. And we'll plug it in over here and check it. And we see that 2 times 18 is 27. Cube root of minus 9 is 27. Cube root of that is 3. Minus 1 is 2. And so it does equal 2. So we're good. All right. So what I want you to do, pause the video, or rewind it if necessary, see how we did that. Work these 3 problems out on your own, then come back and check and see if you got it right. All right, let's see how you did. Number 1, should have got 27. Number 2, you should have gotten negative 21. And 3, you should have gotten 11. So here, let's take a look. If you got those great, you can fast forward a little bit and go to the next set. If not, here we go, we're going to work them out. All right, so first, we write down the problem. Cube root's not by itself. We've got to get rid of the 9, so we add 9 to both sides. Then we take the cube, raise both sides to the third power, cancel out the cube root, and that gives us x equals 27. All right, on number 2, we see the radical is already by itself, so we don't have to move anything over first. So all we're going to do is take the square root of x plus 25, and we're going to square both sides. So we do that, and we end up with x plus 25 equals 4. Subtract 25 from both sides, and x equals negative 21. All right, last one. First, you write down the problem. Uh-oh. Well, I was just writing down the problem. You can see it. Okay. Now, we've got that 2 that's got to go away. So we're not distributing in. Never distribute into the radical. Instead, we're going to divide it out. Divide it over to the other side. So we divide both sides by 2, and we end up with the cube root of x plus minus 3 equals 2. Now we can get rid of that cube root. Get rid of cube root by cubing. So we're going to cube both sides, raise both sides to the third power, which gives us x minus 3 equals 8. Add 3 to both sides, and we end up with x equals 11. All right. Okay, so let's do some that are, let's take a look at this first. So here we have a hurricane. The mean sustained wind velocity in meters per second is modeled by this equation. V of P equals 6.3 times the square root of 1013 minus P, where P is the air pressure measured in millibars at the center of the hurricane. So what we want to do is estimate the air pressure in the center of the hurricane if the mean sustained wind velocity was 54.5 meters per second. All right. So first, we're going to write down our equation. We've got this function here that we can use, so we're going to use that. Now we have this 54.5 meters per second. We need to plug that in somewhere. And this is velocity, so that's going to go in for our V of P over here. So we have this. And now we need to solve this. So we've got a square root equation here. Isolate the radical, so 6.3 has to go away. So we're going to divide both sides by 6.3. Gives us this approximately. Now we have the radical by itself, so we're going to undo square rooting, so we're going to square both sides. And that gives us 74.8 equals 1013 minus P. Subtract the 1013 from both sides. That gives us negative P, though we don't want negative P, so we multiply both sides by -1 or divide by -1, either way. And P is approximately 938.2. So our air pressure in the center of the hurricane is about 938 millibars. Right. So not too bad. Now we're going to look at something that's slightly more complicated. Right. So we're going to solve this one. X plus 1 equals the square root of 7x plus 15. Right. Doesn't look too bad because the radical is already isolated, right? However, our problem with this is that we have x on this other side. We have x plus 1. So when we square this side, when we square both sides to get rid of the square root, what happens, this is not x squared plus 1 squared. This is x plus 1 times x plus 1. So you're going to have to FOIL that together. And when you FOIL it together, you end up with this. So now you have a quadratic function, a quadratic equation rather. And so that's not too bad. We know how to solve those. So we're going to make it equal 0. So we subtract the 7x plus 15 from both sides. And so now it's in standard form. We've got it all set equal to 0. This factors out fairly nicely. So we can solve by factoring. If you like, you can solve it by quadratic formula, complete the square, whatever you like. But factoring is easier, so there you go. Set both factors equal to 0. Solve both of those linear equations there, and we have x equals 7 or x equals -2. Always a good idea to plug these in, check and make sure they work. So we plug in 7. 7 plus 1 is 8. And then we plug in 7 up here. So 7 times 7 is 49 plus 15 is 64. Square root of 64 is 8. So it works. Plug in -2. -2 plus 1 is -1. And 7 minus 2 is 5. Plus 15. Oh, 7 times -2, sorry. 14. -14 plus 5 is 15 is 1. Square root of 1 is 1. And so -1 equals 1. No, it doesn't. -1 doesn't equal 1. And so we've got a problem. This doesn't work. So what we have here, this is called an extraneous solution. It's a solution that looks like it's going to be good, but it really isn't. When you plug it back in, it doesn't work. It doesn't come out. So you're going to need to do that. Like I said, very important to check your solutions, especially if you get 2 of them. But sometimes even if you only get 1, it's a good idea to check them. So anytime you get solutions, if you're squaring something here, always check your quadratics. Check, make sure it works, because sometimes they don't work. So now let's take a look at this one. And this one you'll notice is even more complicated, because not only does it have an x plus 1 on the other side, it has a square root of 3x. We've got square roots. So we've got square roots on both sides here. Can we isolate the radical? Can we get both of these radicals all by themselves? And the answer is no. If I move the 1 off of this side, now I've got it with this radical, right? And I can't combine the 2 radicals because they don't have the same radicands. So what we're going to do is we're just going to go ahead. This one's already by itself. So we'll square it. So if we can square everything, that'll get rid of this radical. So that's what we're going to do. We're going to square everything. This radical is going to go away. This gets foiled together. And that's going to look a little bit weird. Ends up with this. X plus 2 plus 2 times the square root of x plus 2 plus 1. Then over here we just have 3 minus x, which is easy. But here, what you got to do, you got to FOIL all of this together, so it's square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. So that gets a little ugly right there. But now if you notice, we only have one radical. So could we isolate that one radical? Oh yeah, sure. So we're going to move everything else over. Right? Subtract the x here, subtract the 2, subtract the 1, ends up with this. Divide this 2 out, do not distribute it in. And now we've got this radical isolated, we can square both of these. All right? So we square both sides and we end up with x plus 2 equals x squared. That's another quadratic equation, so we want to set this in standard form, put it equal to 0. This will factor out fairly nicely, and so take both these, set them equal to 0, and we end up with x equals 2 or x equals -1. But we do have two solutions, and we need to make sure they work. So let's take a look. Plug in the 2, and we end up with 3 equals 1, and it doesn't. So that's no good. The 2 is no good. Let's plug in the -1. Maybe that'll work. Plug in -1, and we end up with 2 equals 2. So -1 works. 2 doesn't, the -1 does. So our answer is just x equals -1, the only solution we have. And the 2 is extraneous. Alright. So now, I would like you to pause the video, work these 3 out, then come back and see how you did. Alright, let's take a look. Those are your answers. Hopefully that's what you got. If you did, great. You got this down. If not, let's take a look. So number 5, the radical is by itself, so we're just going to square both sides. Gives us this, because remember you got to FOIL that together. Set it all equal to 0. That factors out nicely. Gives us answers of 0 or 4. Plug those back in. Plug in the 0, and we get 3 equals 3. So that's good. Plug in the 4, and we end up with 7 equals 7. So good. Good. So both of these worked. Okay. Sometimes that happens where they both work, which is always nice. Here, both of our radicals are already isolated. So when we square both sides to get rid of one radical, it's actually going to get rid of both of them. And so we end up with this, which is a nice linear equation. And we just work that out, solve it, x equals 2, plug it in, and square root of 9 is square root of 9. 3 equals 3. So it worked. Okay, last one here. Let's take a look. Write our problem. Again, this is one where it's not going to just cancel out and go away. Let me move my face out of the way. There we go. And so we're going to have to FOIL this together, which is going to give us that ugliness that we had before. Right there, x plus 6 minus 4 times the square root of x plus 6 plus 4 equals x minus 2. We're going to subtract everything from both sides to get this radical by itself. So subtract x minus 10. So -4 square roots of x plus 6 equals -12. Divide both sides by -4. Never distribute in. Square both sides, and we end up with x plus 6 equals 9. And so x equals 3. Plug that back in, check it, and 1 equals 1. So it works. All right. And so that is solving radical equations. Some of this can be kind of tricky, especially when you're folding these two together. You got to be real careful with that. Always check your answers. A lot of them will have those extraneous solutions. Put myself up with that. And hopefully that helped, and I will see you next time.